Hello students. So today also I am doing class for class 12 science. The topic is the limit. So in the last class also we were doing this limit of a function and we were proving some standard limits out there. So we did standard limits number 1, 2 and 3. We proved it. Now let us prove number 4. So I think you revised the problem, that is we revised that standard limits which we have done in the last online class. Okay, so now we will prove this number 4 standard limit. What is number 4 standard limit? It is limit x tends to a x to the power n minus a to the power n divided by x minus a is equal to na to the power n minus 1. So let us prove this standard limit. So now in this case limit x tends to a is given. Here x is the variable. So other than x, all other quantities here are constant. You know variable. Variable means whose value changes, that is known as a variable, and whose value do not change, whose values do not change, that is known as a constant. So here x is a variable because its value changes, and here this a, n are all constant because its value does not change. Okay, so let us prove it. Let us prove this LHS is equal to RHS. Okay, so now for this you should know the binomial expansion. So in class 11 you did binomial expansion, isn't it? That is, the binomial expansion was a plus x whole to the power n is equal to, what was the formula? The formula was nc0, right? A to the power n plus nc1 a to the power n minus 1 x plus nc2 a to the power n minus 2 x square plus dot 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 plus ncn x to the power n. This is your binomial expansion. Okay, so if you put a is equal to 1, what do we get? So putting a is equal to 1, so instead of a, if you write 1, so this formula becomes 1 plus x whole to the power n is equal to, what is it? You know nc0, nc0 means 1. You know how to calculate it, nc0, you have done it in class 11 also. So nc0 is always 1. So 1 into a to the power n is a to the power n plus, what is nc1? That is only n. So it is n, oh sorry, this is a is equal to 1 is there. So a is equal to 1 is there, isn't it? nc0 is 1 and a is equal to 1. What is 1 whole to the power n? 1 to the power n number is always 1. Okay. Now what is nc1? It is always n. So nc1 means starting from n there should be only one factor. That is nc1 means n only. And what's about a? A to the power n minus 1 means you put a is equal to 1. 1 whole to the power n minus 1 is 1. So 1 into x is x. So it is 1 plus nx. Plus, what is nc2? Starting from n there should be two factors. So what are the two factors in this case? One is n and the other one is n less than 1. That is n minus 1 divided by 2 is here. That is your factorial 2. And you know that a is 1 always here because we are putting a is equal to 1. So 1 whole to the power n minus 2 is always 1. So it is your x square plus dot 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 plus. What is ncn? Ncn means 1. Starting from n there should be n factors. Starting from n there should be n factors, right? So ncn is always 1 and you should write x to the power n. Is that clear? So you should know this expansion in order to prove this limit. Okay, so now let us write LHS is equal to limit x tends to a x to the power n minus a to the power n divided by x minus a. So let us do the method of substitution out here. So let us assume x minus a as h. Okay, so let h is equal to x minus a. Now let us get the value for x. What is the value for x? So minus a is taken to the left hand side. What does it become? Plus a. So it is a plus h, right? Now you have to change the limit also, because we are changing the variable here. The variable was x and we have assumed x minus a as h. When x tends to a, what does h tend to? When x tends to a, if you put x is equal to a, what is a minus a? 0. So when x is equal to a, then h is equal to 0. That means when x tends to a, h tends to 0. Is that clear? So we are changing the limit. We have to change the limit. While doing here the method of substitution, you should change the limit also. That means when x tends to a, h tends to 0. So now this limit becomes, so LHS is equal to limit x tends to a means h tends to 0, right? What is the value for x? A plus h whole to the power n minus a to the power n. This whole divided by, what is x minus a here? It is h. Is that clear? Next, which is equal to limit h tends to 0. Let us simplify it further. So now within second bracket, now a plus h is there. Let us take a as common out here. Okay, let us take a as common. Okay, a is taken common, so within bracket what do we get? Already a is taken common here, so it is 1 plus, then what do we write here? H upon a, second bracket close, whole to the power n. Then what do we write? Minus a to the power n, whole divided by h. Is that clear now? So you can copy it, or you can pause the video and copy it. So let us simplify it now. Okay, so let us simplify it. So now what do we get? What do we get now? Limit, this is your h tends to 0. Now this power n is for both these factors, isn't it? This power n is for both a as well as 1 plus h by a. So what do we get? A to the power n into 1 plus h upon a whole to the power n. Then what do we get? Minus a to the power n whole divided by, this is your h. Is that clear now? So I think you have understood it. So in the next step, what will you do? We can take common out here. A to the power n is common here. So which is equal to limit h tends to 0. So here a to the power n is common. It is taken common, a to the power n. So within second bracket, what do we have? 1 plus h upon a whole to the power n minus 1. This whole divided by h. So is that clear now? So what will you do in the next step now? So in the next step, what will you do? Now you have to again simplify it. Now here limit h tends to 0. Now h is the variable here. Here it is given limit h tends to 0. So h is the variable and all other terms are constant here. So a to the power n is constant out here because it is free from h. Right? So it should be taken outside limit. So the constant term can be taken outside limit. So a to the power n into limit, this is your h tends to 0. Now we can use your binomial expansion. We can use this expansion. Instead of 1 there is 1, instead of x there is h by a, and for power n here is also power n. We can use this expansion now. So what is the expansion here? So let us write down the expansion. 1 plus, what is n out here? This is n into, what is x here? It is h by a, right? Then plus, then n into n minus 1, n into n minus 1 divided by factorial 2 into, what is x whole square here? It is h by a whole square. This is your h by a whole square. Then what do we write? Plus dot 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 plus, what is the value for x in this case? Plus x to the power n will be there. So instead of x, what is there? h by a. So it is h by a whole to the power n. So this is your expansion for 1 plus h upon a whole to the power n, and this expansion is known as binomial expansion that you did it in class 11. Okay, then write down minus 1. So this whole divided by, that is your h. Is that clear? So here this plus and minus 1 will be cancelled. Is that understood now? So you can take common out here now. What is common out there? This is h. So is equal to a to the power n into limit h tends to 0. Now here h is common, right? So within third bracket, what do we get? Here h is taken common. All these terms contain h out here. So we have taken h common now. So it is n by a plus, here it is n into n minus 1 divided by factorial 2 into, here h is taken common. So it becomes, what does it become now? It is h upon a square plus dot 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 plus. So actually this is h to the power n, but h is taken common here. So what do we get here? H to the power n minus 1 divided by a to the power n, right? So third bracket is closed, and what do we get here? We get h out there. So here h gets cancels. So I think you have understood it. So let us simplify it again. So now in the next step, write down the remaining terms. A to the power n into limit, this is your h tends to 0. So within third bracket, what do we have? N by a plus n into n minus 1 divided by factorial 2 into h by a square, right? Is that clear? Yes, I'm a plus dot 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 plus. The last term say ke cha here. What is the last term out here? This is h to the power n minus 1 divided by a to the power n. Now third bracket is closed. Okay. Now from the second term, all the terms contain h. So we can put the limiting value of h, that is 0. So instead of h, we can put 0 out there, right? So instead of h, you put 0, a to the power n into, now within third bracket, this will be n by a. So n by a is a constant because it is free from h. Okay, so you don't have to put the value of h out here because it is free from h. So it remains as it is, that is n by a plus n into n minus 1 divided by factorial 2 into 0 by a square. All the terms contain h out here, that is also 0, plus it is 0 to the power n minus 1 whole divided by a to the power n, right? So next, a to the power n within third bracket n by a plus, from the second term it will be 0 plus 0 plus 0 etc. up to infinity, that is 0. So which is equal to a to the power n into n by a, which is equal to, what is the answer here? N is constant into a is also constant, a to the power. When a goes up in the numerator, it becomes minus 1, isn't it? A to the power n into a to the power minus 1, which is equal to n into a to the power n minus 1. That is proved. That is standard limit. Limit x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. So this standard limit is proved. So I think you have understood it. Okay, you can copy it. So now we'll do the next standard limit. Now we'll prove next standard limit now. So the next standard limit is, so write down next standard limit, that is number 5. Next standard limit is limit x tends to 0 log of 1 plus x base e whole divided by x, which is equal to 1. So let us prove it now. So LHS is equal to limit x tends to 0 log of 1 plus x base e whole divided by x. Now this is your logarithmic series. So this logarithmic series is also an infinite series. Log of 1 plus x base c is equal to, its formula will be x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus dot dot dot, it goes up to infinity. That means it is also an infinite series. Logarithmic series, this is known as logarithmic series. This logarithmic series is also an infinite series. Okay, so which is equal to limit x tends to 0. Let us put the formula for log of 1 plus x. What is it? X minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus dot dot dot, it goes up to infinity. Whole divided by x is there. Okay, now in this case, in the numerator you can take x as common, so is equal to limit x tends to 0. Here x is common, within bracket what do we get? 1 minus x is taken common. So if you take x as common, so within bracket what do we have? 1 minus x by 2 plus x square by 3 minus x cube by 4 plus dot dot dot, it goes up to infinity. So whole divided by x. Okay, so here you can cancel this x is cancelled now. So write down the remaining terms. Limit x tends to 0, within bracket 1 minus x by 2 plus x cube by 3 minus, this is x square by 3 minus x cube by 4 plus dot dot dot, it goes up to infinity. Okay, now you can put the limiting value of x. Here the limiting value of x is 0, so you can put x is equal to 0. Okay, so if you put x is equal to 0, what do we get? So is equal to limit x tends to 0, 1 is a constant term, you can write 1 minus it is 0 by 2 plus 0 square by 3 minus 0 cube by 4 plus dot dot dot, it goes up to infinity. So from the second term all the terms will be 0, so which is equal to 1 minus, that is your 0. So 1 minus 0 is always 1. 1 minus 0 is always 1. So this is the answer. So I think you have understood it. Okay, so you can copy it. Now we'll do next standard limit. We'll prove the next standard limit now. So now we will prove the next standard limit, that is your number 6. What is number 6? Limit x tends to 0, e to the power x minus 1 whole divided by x is equal to 1. Now e to the power x is known as an exponential function. It has an infinite series again. So its formula is e to the power x is equal to 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus dot dot dot, it goes up to infinity. That is also an infinite series. Okay, so let us prove it again. So we can use the formula for e to the power x as an infinite series in this case. So LHS is equal to limit x tends to 0, e to the power x minus 1 whole divided by x is equal to limit x tends to 0 now. So what is the formula for e to the power x? You can write down that series, isn't it? So 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube by factorial 3 plus dot dot dot, it goes up to infinity. Okay, then minus 1 is there, so write down minus 1 whole divided by this is x. Okay, so here this plus 1 minus 1 gets cancels, and from this second term what is common out here? x is common. So you can take common. So limit x tends to 0, x is taken common. So within bracket, what do we get? It is 1 by factorial. 1 means 1, isn't it? What is factorial? You know factorial notation, I think. You did it in class 11. Okay. So plus, it is x upon factorial 2 plus x square by factorial 3 plus ... It goes up to infinity. This whole divided by x. Is that clear? So you can cancel this, x's gets cancels, which is equal to limit. This is your x tends to 0. So within bracket, what do we have? 1 by 1 is 1 plus x upon factorial 2 plus x square by factorial 3 plus ... goes up to infinity. Now you can put the limiting value of x. Here the limiting value of x is 0. That means instead of x you can put 0 out here. Okay. So is equal to 1 plus 1 is a constant quantity. You don't have to write limit out here. So 1 plus, it is 0 by factorial 2 plus 0 square by factorial 3 plus ... It goes up to infinity, right? From the second term, all the terms will be 0 up to infinity. Okay. So which is equal to 1 plus 0, which is equal to 1. Proved. So we have proved that standard limit number 6. Okay. So now, so you can copy it. Now we will prove that number 7. That is standard limit number 7. Okay. So let us prove standard limit number 7 now. So I think you have copied it. You can pause the video and you can copy it. So next, number 7. What was number 7? Limit x tends to 0, a to the power x minus 1 whole divided by x, which is equal to not 1, which is equal to, this is log a base e. This is your log a base e. Okay. So now in this case you should know a formula there. So you know that e to the power log x base e is equal to 1. You should know this formula. Sorry, this is x. Limit, not limit, e to the power log x base e is equal to x. This is e to the power log, here is also the base is e. These two are same. If it is e, this base must be e. So e to the power log x base e is equal to x. Okay. We can prove it also. Let us prove it. Let e to the power log x base e is equal to k. Now we should prove that k is equal to x. Just try to understand it. Okay, you don't have to prove it. Okay, just I am showing you the proof, but just try to understand it. Don't copy it. Okay, but you have to remember this formula, that is e to the power log x base e is equal to x. I think you know it. Okay, so let us prove it. Let us assume that e to the power log x base e is equal to k. Okay, अब हामी के गर्नुपर्छ भन्दाखेरि यो log x base e, यो log x base यो अगाडि लिनुपर्छ. So both the sides हामी के लिन्छौं, log लिन्छौं. So taking log on both the sides, taking log on both the sides. So taking log on both the sides, what do we get? That is log e to the power log x base e is equal to log k. So if there is no base, there should be base e. If the base is not written there, the base is e. So write down base e. Now because of this log, you know from properties of logarithm, if there is log, this power becomes the coefficient. That means log x base e comes in the front. That is, it will be log x base e into log e base e is equal to, this is your log k base e. Right? And now what is log e base e? It is always 1. You know that. So it is log x base e is equal to log k base e. So from both the sides you can cancel that log, but don't write log in the next step. So what do we get? That is your x is equal to k, or you can have k is equal to x. That means this k is equal to x. This k is equal to x. So we have proved that e to the power log x base e is equal to x. Okay. So here we have proved that e to the power log x base e is equal to, what was the value for k here? K is equal to x. So we have proved it. So I think you have understood it. So how did we get this e to the power log x base e is equal to x? I think you have understood it. Okay. So timale you prove garirahनु पर्दैन, just try to remember this one. You have to memorize it. Okay. So e to the power log x base e is equal to x. Okay. And now, since a to the power x is there, right? So instead of x, you write a to the power x. So e to the power log a to the power x base e is equal to, what is that? That is your a to the power x, isn't it? So that is, instead of x, we are writing a to the power x. Right? So instead of x, we have written here a to the power x. So actually, what is a to the power x? How will you write it? A to the power x can be written as is equal to e to the power log a to the power x base e. Right? So let us write it here. So this left hand side is equal to limit x tends to 0 a to the power x minus 1 whole divided by x, which is equal to limit x tends to 0. Now instead of a to the power x, what can you write? You can write e to the power log a to the power x base e. Then write down minus 1 whole to the power x. Now this is just like your exponential function e to the power x. Instead of x, what is here? Log a to the power x base e. Is that clear? So यो के जस्तो भयो भन्दाखेरि e to the power x जस्तो त यो. त x को सट्टामा चाहिँ के आयो? Log a to the power x base e. Now we can use this formula again. E to the power x is equal to, what was the formula? 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube by factorial 3 plus dot dot dot, it goes up to infinity. Is that clear? But because of this log, this x becomes the coefficient out here. So first of all, in the power, you should write x in the front. Because of this log, this x becomes the coefficient out here. So which is equal to limit, this is your x tends to 0, e to the power here, it is x log a base e minus 1 whole divided by x. So now, instead of x here, what is there? X log a base e. So you can use this formula now. Is that clear? We can use this formula because instead of x, what is here? It is x log a base e. So let us use the formula now, which is equal to limit, this is your x tends to 0, right? Now e to the power x log a base e. So you use this formula. So 1 plus, what is x upon factor 1 here? X log a base e divided by factorial 1 plus, right? And the next one is, what is the next one here? What is x square here? It is x log a base e whole square divided by factorial 2 plus, next what is whole cube here? It is x log a base e whole cube whole divided by root over 3 plus dot dot dot, it goes up to infinity. So after this term there will be a term containing x, okay? So plus dot dot dot, it goes up to infinity, then you write down minus 1. Minus 1, this whole divided by what is there? It is x. Is that understood? So here plus 1 and minus 1 will be cancelled. You can cancel it, okay? So next, what will you do now? You can simplify it further. So which is equal to limit x tends to 0. Write down the remaining terms here. What are the remaining terms? X log a base e by factorial 1. You know that this factorial 1, factor 1 is 1, plus this is your x square log a base e whole square divided by factorial 2, right? Plus x cube into log a base c whole cube divided by factorial 3, plus it goes up to what? Plus it goes up to infinity. Plus there are all the terms containing x here. Third bracket is closed. This whole divided by x. So I think you have understood it. So now in the next step, what will you do? From the numerator you can take common, isn't it? So what is common out there? It is limit, which is equal to limit x tends to 0. What is common out here? X log a base c, or you can take only x as common. Only x you can take as common out here. So x is taken common. What do we get? Log a base c plus x into log a base c whole square divided by factorial 2 plus this is your x square into log a base c whole cube divided by factorial 3 plus dot dot dot, it goes up to infinity, right? So here third bracket is closed, then this whole divided by x. So here you can cancel this x, you can cancel them, right? So you can cancel it. So write down the remaining terms now. What are the remaining terms here? Which is equal to limit x tends to 0 within third bracket. This is your log a base c plus x into log a base c whole square divided by factorial 2 plus then this is x square log a base c whole cube divided by factorial 3 plus dot dot dot, it goes up to infinity. Is that clear to all of you? So now you can apply limit out here. Since this term is free from x, this is a constant quantity, so you don't have to write limit out here. So it remains as it is, that is log a base c plus, in this case you can write down the limiting value of x. X tends to 0 means 0 is the limiting value of x, but we can put x is equal to 0 out here. So 0 into log a base c whole square divided by factorial 2 plus this is your 0 square log a base c whole cube divided by factorial 3 plus dot dot dot, it goes up to infinity. So all the terms from the second term will be 0. So which is equal to now we can write here, which is equal to log a base c plus, from the second term this will be 0, right? So from the second term all the terms will be 0 because x is equal to 0 out here. So what is this value? Which is equal to log a base e. So it is proved. That is, limit x tends to 0, a to the power x, first term minus 1 whole divided by x will be equal to log a base e, proved. Okay, so we have proved 7 standard limits out here. That is, number 1 was limit x tends to 0, sin x is equal to 0, you know that. And the second one was limit x tends to 0, cos x is equal to 1. Third one is limit x tends to 0, sin x divided by x is equal to 1. Fourth one was limit x tends to a, in the numerator x to the power n minus a to the power n divided by x minus a, which is equal to n into a to the power n minus 1. You can check your copy. And formula number 5 was limit x tends to 0, in the numerator log of 1 plus x base c whole divided by x is equal to 1. And then next, sixth formula was limit x tends to 0, e to the power x minus 1 whole divided by x is equal to 1. And the last one, that is, we just prove it, that is formula number 7 or standard limit number 7 was limit x tends to 0, a to the power x, first term, second term minus 1 whole divided by x is equal to this one, log a base e. So we have proved all these standard limits. Okay, now we will use these standard limits to do some problems. Okay, now let's do some problems now. So now we will do this problem. You have to find out the value of this limit. So here the limiting value of h is 0. If you put h is equal to 0 directly, it will be 0 by 0 form. That is known as indeterminate form. I told you about this. 0 by 0 is indeterminate form. That is your undefined. So you should have the finite limit. That means this limit should be a defined limit. So how can you get it? Okay. So which is equal to, now in this case, e to the power x plus h whole square minus e to the power x square is there. You take common out here. So what is common here? E to the power x square is common. So limit h tends to 0, e to the power x square is taken common. So within second bracket, what do we get? E to the power x plus h whole square minus x square, isn't it? Is that clear? So how did you get this one? Like if you have e to the power 7 minus e cube, right? E to the power 7 minus e cube. What is common here? Common out here? E cube. So what do we get within bracket? So e to the power 4 will be there, you know that. But how did you get that 4? You have to decrease the power 7 by 3. That is 7 minus 3. Then only you will get 4, isn't it? So minus 1. So likewise, here e to the power x square is common. So e to the power x square is taken common out here. So within second bracket, what do we get? E to the power, this is your x plus h whole square. Then this x square should be minus out here. You should subtract this x square from x plus h whole square. That is, you will get x plus h whole square minus x square. Then minus, this is taken common out here, so it is 1. Second bracket is closed. This whole divided by h. So I think you have understood it. Okay. Now you should convert it into a standard limit. So what is that standard limit? So in this case, we can use the standard limit, that is limit x tends to 0, e to the power x minus 1 whole divided by x is equal to 1. So we can use this standard limit out here. So instead of x, what is here? Instead of x, what is here? It is x plus h whole square minus x square, right? So it is e to the power x minus 1 divided by x form should be there. But what is x in this case? X plus h whole square minus x square. मैले भनेको बुझ्दैछ? हामीले यो लिमिटलाई, हामीले यो फंक्सनलाई हामीले यो फर्ममा लानुपर्छ. E to the power x minus 1 whole divided by x. So instead of x, what is here? X plus h whole square minus x square छ यहाँ. So e to the power x minus 1 whole divided by x should be there. तर x भने के आयो? x plus h whole square minus x square आउँदैछ. त हामी यो स्ट्यान्डर्ड फर्ममा लान्छौँ यसलाई. So is equal to limit x tends to 0, e to the power x square into, this is your e to the power x plus h whole square minus x square minus 1 whole divided by. So e to the power x, x को value कति छ यहाँ? X plus h whole square minus x square. So it should be divided by x. But actually what is x here? X plus h whole square minus x square into. तर यो त हामी आफै लेखेको नि त. We are writing ourselves, that is x plus h whole square minus x square. But it should be cancelled. हामीले यसलाई क्यान्सल गर्नै पर्छ. त यसलाई क्यान्सल गर्नलाई न्युमरेटरमा हामी के लेख्छौँ? X plus h whole square minus x square. This divided by what? This is h. So I think you have understood it. Okay. So let us simplify it. So is equal to, oh sorry, this is h tends to 0, not x. This is your h tends to 0. That means which is the variable out here? If it is given limit h tends to 0, so h will be the variable. In this case, h will be the variable, but all other terms will be constant here, right? So e to the power x square is constant because it is free from h, so it is taken outside. So e to the power x square into limit, this is your h tends to 0, right? So it is e x plus h whole square minus x square minus 1 divided by x plus h whole square minus x square into, here also you can write down the limit. What is that limit? Limit h tends to 0, This is your x plus h whole square minus x square divided by h. Is that clear? Now you know that this is the standard limit. It is just like your limit x tends to 0, e to the power x minus 1 whole divided by x is equal to 1. This is also the standard limit, right? This is also the standard limit. What is the value of this limit? That is your 1. Because it is in the form e to the power x minus 1 whole divided by x. What is the value of this limit? That is always 1. So right here, which is equal to e to the power x square into 1 into. Now in this case, this is not your standard limit. You have to simplify it now first. Okay. So limit s tends to 0. Now simplify the numerator now. What is x plus h whole square? It will be a plus b whole square, x square plus 2xh plus h square. Then what do we write? Minus x square whole divided by h. Is that clear? So here you can cancel this x square gets cancelled. You can cancel them. Now in the next step, e to the power x square into 1 is e to the power x square into limit. This is your h tends to 0. So what is common in the numerator? That is your h is common out here. So h is common within bracket. What do we get? It is 2x plus h, this whole divided by h. This h gets cancels. So which is equal to e to the power x square into limit h tends to 0 within bracket, it is 2x plus h. Now you can put the limiting value of h, which is equal to 0. 0 is the limiting value of h. So you can put h is equal to 0 in this case. So which is equal to e to the power x square into 2x. Because 2x plus 0 is always 2x. So what is the answer here? 2x e to the power x square. So this is the final answer. So I think you have understood it. So let us do the next question now. So you can copy it. Now we'll do question number 2 of number 1. Here also you have to evaluate. Evaluate means you have to find out the value of this limit. You have to find out the limiting value of this function when x tends to 0. Now in this case we can use two standard limits. That is, one is limit x tends to 0, e to the power x minus 1 whole divided by x is equal to 1. And what is the other one? That is limit x tends to 0 sin x by x, which is also 1. Is that clear? Now you should convert both this numerator and the denominator into standard limit form. It should be e to the power x minus 1 whole divided by x. So e to the power x form, instead of x there is 2x. Here it should be in the form sin x by x, but in this case instead of x there is 3x. So first of all you have to divide both the numerator and the denominator by x. So which is equal to limit x tends to 0, e to the power 2x minus 1 divided by x divided by, it is sin 3x divided by x. So we are dividing both the numerator and the denominator by x to convert them into standard limit. Okay. Now in this case, in the numerator, instead of x there is 2x. So again this should be multiplied by 2. In the denominator it should be multiplied by 2, and that should be cancelled, and you should again multiply it by 2. But it should be in the form sin 3x by 3x form. So you should multiply it by 3, but that 3 should be cancelled. You should write here 3. So which is equal to limit, this is your x tends to 0, right? So what do we write here? E to the power 2x minus 1 divided by 2x. But we are multiplying this x by 2 ourselves. But you should cancel it. So into, what should you write? 2 divided by, in the denominator also you should write it in the form sin x by x form. But what is x here? It is 3x. So it should be sin 3x divided by 3x into These 3 should be cancelled. So what do we write? Into 3. Okay. So these 3 will be cancelled and you'll get the same expression. This 2 will be cancelled, you will get the same expression out here. Okay. Now this 2 by 3 is constant. You can write it before limit. Okay. And now wherever there is x, wherever there is standard form, you should write down the limit out here. Okay. Now is equal to, now in the next step, this 2 by 3 is constant, you can take it outside, into, you have to write down limit for both these expression which are in the numerator and in the denominator. So you should write here limit x tends to 0. So e to the power 2x minus 1 divided by 2x, this whole divided by, in the denominator also you should write down the limit, that is limit x tends to 0. Then what do we write? Sine 3x divided by 3x. So I think you have understood it. So which is equal to 2 by 3 into, what is the value of that limit in the numerator? That is always 1, divided by, what is the value of the limit in the denominator? That is also 1. These are all the standard limit. Just now we have written out here. That is limit x tends to 0, e to the power x minus 1 all divided by x is equal to 1. And the other one is limit x tends to 0, sin x by x is equal to 1. So the value of this limit is 1. The value of this limit is also 1. So which is equal to, what is the limiting value of the given function? It is 2 upon 3. So I think you have understood it. So this much is for today. So revise all the problems that we did today. So in the next class, we'll do more problems on this limit. Okay.